Hi, this lesson is about solving rate of work word problems. The formula we'll be using to set up these problems is rate times time equals the part of the job done. So we'll be using the letters R times T equals P. Now, what is R? R will be the rate that it takes a single person or machine to perform a task. The rate is always written as a fraction. So, for example, if it takes me 4 hours to grade the exams for a class, then my rate of work would be 1/4, because for every 1 hour, I have completed 1/4 of the job. So, whatever the total amount of time is, you put that number over 1, and that will be the rate of work or rate that it takes someone to complete a task. Time, or T, will be the time that it takes 2 or more persons or machines to perform a task. And P is the part of the job or task that is done by the person or machine. The sum of all of the parts must always equal 1. 1 represents one whole job or task completed. So here are a few examples. Solve each of the following. One printing press can print the first edition of a book in 55 minutes. A second printing press requires 66 minutes to print the same number of copies. How long would it take to print the first edition of the book with both presses operating? Okay, so you're given the rate of each printing press. The first one is 55 minutes, so you write that as 1 over 55. The second one is 66 minutes, so you write that as 1 over 66. You're trying to figure out how long it takes to print the book if both printing presses are working at the same time. So that's your unknown. So you put a variable in the time column. So I chose T. You can pick X or any other variable that you like. Rate times time equals the part of the job done. So you multiply the first two columns. So that's what you see here. The part of the job done by the first printing press is T over 55. The second one's part is T over 66. And remember, when the whole job is done, that equals 1. And that will always be the case in these types of problems. So your equation is T over 55 plus T over 66 equals 1. This is a rational equation. So the technique is to identify the LCD and multiply both sides by the LCD. The lowest common denominator for 55 and 66 is 330, which is what I did here. Multiply both sides by 330, and that will cancel your denominators. So 330 times T over 55 leaves me with 6T, and 330 times T over 66 leaves me with 5T. 6T and 5T gives us 11T. Don't forget, we also multiplied the right side by 330. So you have 11T equals 330. When you divide by 11, you get that T is equal to 30. So what does that mean in terms of this word problem? It means that it takes 30 minutes to print the book if both printing presses are working at the same time. Okay, let's try another example. So this one, it says, a new printer can print checks in 3 times faster than an old printer. The older printer can print the checks in 48 minutes. How long will it take to print the checks with both printers operating? All right, so we have an old printer whose rate is 1 over 48. The new one is 3 times faster, so if you take 48 and divide it by 3, that's 16. So the rate of the new printer is 1 over 16. Again, we want to know how long it would take to print the checks if they're both working at the same time, the old printer and the new printer. So once again, that is your unknown, and I'm using T. So P is rate times time, so we get T over 16 and T over 48, and when the whole job is done, that equals 1, right? So that's your equation. T over 16 plus T over 48 equals 1. The LCD for 16 and 48 is 48. Multiply both sides, don't forget to multiply the right side as well, by 48. When you simplify, you get 3t plus t equals 48. So that's 4t equals 48. Divide by 4, and you get that t is equal to 12. So in terms of this problem, it takes 12 minutes to print the checks if both printers are working. Okay, let's do another one. Here, different information is given, so we'll be solving for something other than time. So it says a welder requires 18 hours to do a job. After the welder and an apprentice have been working on a job for 6 hours, the welder moves to another job. The apprentice finishes the job in 14 hours. How long will it take the apprentice working alone to do the job? So you're told that if the welder was working alone, it would take him 18 hours. So his rate is 1 over 18. You're trying to figure out how long it would take the apprentice to complete the job on his own. That's your unknown. So I'm going to call that 1 over r. Remember, your rate should always be a fraction in rate of work problems. So don't just put r or x there. You want to write 1 over r. Time. Remember, time will be how long someone has been working on a job together. So the welder and the apprentice are working together. The welder works on the job for 6 hours, then he leaves and goes to another job. The apprentice finishes up and his time on the job has been 14 hours. So we put 6 and 14 under time. Part of the job done is rate times time. So the welder's part of the job done is 6 over 18. But that's a fraction, and if you can simplify, it's easier to work with smaller numbers. 6/18 is the same as a third. In other words, the welder has done a third of the job before he moves on. The apprentice did 14 over r of the job because we don't know what r is. That's what we're trying to figure out. Okay, so your equation is 1/3 plus 16 over r equals 1. Now, the LCD is 3r. Multiply the left side and the right side by 3r. On the left side, when you distribute, you get r plus 42, because 3 times 14 is 42, and the r's cancel. Then you need to get your r's on the same side. The right side is 3r. Subtract r from both sides. You get 42 equals 2r. Divided by 2, and you get that r is 21. What that means is that if the apprentice was doing the job on his own, it would take him 21 hours to complete the job. Okay. In this case, we have 3 machines. We have 3 computers that can print out a task in 12 minutes, 18 minutes, and 36 minutes, respectively. How long would it take to complete the task with all 3 computers working? All right, so we have computer 1, 2, and 3 here. Their rates are given as 12 minutes, 18 minutes, and 36. Remember, write those as fractions, 1/12, 1/18, and 1/36. We want to know how long it takes to complete the task when all 3 computers are printing. So again, t is your unknown. Part of the job done is the product of rate and time. So I get t over 12, t over 18, and t over 36. And when the whole job is done, it equals 1. So that's your equation. The sum of all of the parts equals 1. The LCD is 36. Multiply both sides by 36. That will cancel all of the denominators, leaving you with 3t plus 2t plus t equals 36. Simplify the left side, so that gives you 6t equals 36. Dividing both sides by 6 gives you t is equal to 6. So what that means in terms of this problem is that it takes 6 minutes to print the task when all 3 computers are working at the same time. Okay, so that's it for this lesson. Give the homework a try. Good luck.